Just imagine an electric light bulb suddenly starts emitting X-rays. Yeah, X-rays, the extremely harmful, ionizing, penetrating X-rays. Exactly that is the case with certain household electric bulbs. Let's check it out. The incandescent light bulbs, which are the predecessors of our CFL and LEDs. The traditional incandescent light bulb. It consists of a glass envelope containing a mixture of inert gases at certain pressure range, and of course there is tungsten filament. The passage of electric current through that tungsten filament causes its incandescence, and that emits visible light like this. Yeah. Now the gases inside this glass envelope is typically the mixture of inert gases like nitrogen and argon, and the pressure of those gases maintained inside the bulb is typically 70 kilopascal. Yeah, but this typical gas pressure combination was not always the case. I am talking about vintage bulb. Yes, I am talking about vintage Edison bulbs and the gas pressure therein. Let us see. All right, now let's take a look at vintage Edison bulbs. You can see here the vintage bulbs with long tungsten filaments. Okay, now just like modern incandescent bulb, these vintage Edison bulb also consisted of glass envelope and neutral gas therein. But the major difference between modern bulb and vintage Edison bulb was about gas pressure therein. Modern bulb contain nitrogen argon mixture at 70 kilopascal. However, the gas pressure inside vintage Edison bulb was comparatively quite low. That means vintage Edison bulb had very good vacuum therein. Okay, and the another difference is the long filament. Let me show you. Here is another Edison bulb, and if you can see, there are multiple long tungsten strands are there. I will try to show you with other couple of vintage bulbs. Multiple tungsten filaments are there. Maybe we can see it here on the proper background, or we can see the incandescence here, quite a long tungsten filament. And I would like to mention this tungsten filament was preceded by multiple other filaments like carbon filament and bamboo filament and stuff like that. All these filaments emitted visible photons by incandescence. Beautiful. Okay, we just saw the beautiful incandescence of this long tungsten filament because I was applying comparatively lower voltages with my variac transformer. Now, what if I apply a bit higher voltage to this vintage Edison bulb? The higher voltages maybe with this flyback transformer EHT from old age television sets, or maybe with my homemade Marx generator. And we can guess the higher voltages applied to this Edison bulb will produce the beautiful glass wall fluorescence and quite harmful X radiation. Let's try it. All right, before we start, let me underline three important precautionary measures. Please do not try this thing at home. Even the professionals should use proper precautionary measures like lead apron, lead collar, and lead glasses. Second thing, while using the high voltage, please do not apply the electrode directly on the glass wall of vintage Edison bulb, because this can rupture, this can puncture the glass wall and make the bulb useless. Instead, we can use the aluminum foil as electrode like this. The foil is going to be our anode and this is going to be our cathode. Okay. And third thing, for the safety of your camera and your scientific gadgets, please don't forget to apply these Faraday shields for your camera, for your Geiger counter, and of course for your scintillation detectors. All right, let's start, guys. Let's apply the high voltage now. Beautiful. The fundamental particles in action. The electrons striking the glass wall, producing green fluorescence of the glass, and also the glass wall is emitting X-rays, the breaking radiation. Let's also apply the high voltage to other couple of Edison bulbs. Yeah, equally beautiful. The glass wall fluorescence and X-ray emission from both the bulbs. Here is another Edison bulb producing X-rays and glass wall fluorescence. Yeah, the Geiger counter is detecting the X-rays emitted by vintage Edison bulb. Substantial amount of X-rays are being emitted from both the bulbs. Now, the similar higher voltage is being applied on vintage Edison bulb and modern incandescent bulb simultaneously. Let's check out the difference. The vintage bulb is glowing, but not the modern bulb. You can easily find the difference, how vintage bulb is producing green fluorescence and X-rays, but that is not the case with the modern bulb. So the pressure difference and the voltage applied, that changes everything. See another comparison between a vintage bulb and modern incandescent bulb. So the beautiful glass wall fluorescence and extremely harmful X radiation. Now let's verify the X-rays with radiographic films and the intensifier screen, and let's compare it with the professional X-ray tube. So should we try Crookes radiometer or some plasma balls, and what's about this cathode ray tube? Let's try them. Let us measure the frequency and energy of the X-rays emitted in kilo electron volt with some gamma spectrometer like Radiacode. Let's also check the rectifier vacuum tubes and some special purpose modern bulbs. And wait a minute, what about my homemade X-ray tubes? So thank you guys, thanks for watching, and stay tuned for the next part of the video, and please do not forget to like, share, subscribe and press the bell icon. Thank you.